Good morning. Today we are going to discuss about first law of thermodynamics. So this is in your second unit. So the topics in the second unit are we are going to discuss about Joules experiment and which is based on first law of thermodynamics and corollaries of first law of thermodynamics. So first law of thermodynamics can be applied to a process and also for a cycle. So those two we will study in the second unit. First law applied to a process and first law applied to a closed system, and definitions of CP and CV, specific heated constant pressure and specific heated constant volume. So both we will discuss in second unit. And these are the terms that are introduced in the second unit: internal energy and enthalpy. And some SFE, steady flow energy equation, we will derive, and the application of steady flow energy equation to various components such as nozzle, turbine, compressor, and heat exchanger we will study, and perpetual motion machine of first kind. So these are the topics we will study in our second unit. So in today's class, we will discuss about first law of thermodynamics, Joules experiment, and what are the corollaries of first law of thermodynamics. So coming to the first law of thermodynamics, so basically, as we seen in our previous lectures, there are four laws of thermodynamics. Zeroth law, three laws: zeroth law, first law, and second law of thermodynamics. Zeroth law is based on temperature. So based on the zeroth law only, measurement of temperature will be done. So coming to the first law of thermodynamics, the basic principle of first law of thermodynamics is principle of conservation of energy. So conservation of energy means energy will neither be created nor be destroyed. That means energy will not be destroyed or new energy will not form, but the energy that is there will be converted from one form to another form. That means kinetic energy may be converted into potential energy, or heat energy may be converted into work, or any form of energy can be converted from one form to another form without destroying or without creating new one. Okay, so this is the principle of conservation of energy, and the first law of thermodynamics is an expression of principle of conservation of energy. And coming to the limitations of first law of thermodynamics, so actually first law of thermodynamics only just transforms one form of energy to another form of energy. That means heat is converted to work or work is converted to heat. Okay, it only maintain the energy balance. So this is the limitation. Beyond that, it cannot do anything. First law of thermodynamics. So this is the first limitation of first law of thermodynamics. That is, first law states that energy only transforms from one form to another. That means heat is converted to work or work is converted back to heat. Okay, that means energy balance can only be maintained by this first law of thermodynamics. And second limitation is this law fails to state the condition under which, it will not state the conditions under which the energy conservation will take place. Okay, so this is the drawback of first law of thermodynamics. And third, the limitation is, so any change of thermodynamic state, so change of thermodynamic state from one state to another state can be take place in either of the direction, but it is not true. Okay, that means if heat is converted to work, the state of change cannot be taken either direction. So, and the fourth limitation is process proceeds spontaneously in certain directions, but not in the opposite directions in the real life. That means if we are assuming all the processes to be ideal process, that means, so if the process take place from state 1 to state 2 following a certain path by releasing some amount of work, that means that if it is giving some amount of work energy, so in the opposite direction also it cannot travel in the same path in the real life. Okay, so even though if we assume the reversal process and which does not violate this first law of thermodynamics. So these are all the limitations of first law of thermodynamics. So first law of thermodynamics is an expression of principle of conservation of energy. Okay, that means heat is converted to work. So coming to the examples of limitations of first law of thermodynamics. So if you take any liquid in a stirrer, so if you take any liquid in a closed vessel, so if you take a closed vessel and if you pour some liquid into the closed vessel, so if you, with the help of the stirrer, if you stir this liquid, okay, for example, so if you take any vessel here, so inside the vessel, if you place any stirrer here, so if you continuously go on stirring this liquid with the help of this stirrer, so what happens is the work that is done by the stirrer. So rotation of the stirrer is the work. Okay. So this energy, this work energy is converted into change in this temperature. That means heat energy. So this is heat Q, heat energy. Okay. So that means work is converted to heat here. So within the rotation of the shaft, the temperature of the liquid will increase. Okay. So if the reversal is not possible here, that means if you go on supplying heat, this stirrer itself cannot stir. Okay. So this is the violation of first law of thermodynamics, or this is the limitation of first law of thermodynamics. And another example we can take is electrical current. So if we take any resistor, if electrical current is flowing through a resistor, it will produce heat. Okay, the reverse cannot be possible. That means electrical current once dissipate cannot be converted again back into initial states of electricity. So the reverse is not possible. So if you supply heat energy to resistor, it cannot produce a electrical energy. Okay, so these are the non-reversible process, which are the limitations of first law of thermodynamics. Okay, so these two examples also indicates that first law fixes the change of exchange rate between heat and work and places no restrictions on the direction of the change. That means, so these two examples indicates only the transfer of work and heat, but does not specify that in which direction the heat and work are flowing. So the direction it will not specify, but only the amount of heat and work that will exchange only we will talk about in first law of thermodynamics. And next one is, in real life, process will take place from one direction. That means temperature can exchange from higher temperature body to lower temperature body. Okay, but the reverse is not possible. The temperature cannot flow from cold body to hot body. Okay, in real life, so this reversible process does not take place. So this is the second limitation. And firstly, first law provides a necessary but not sufficient condition for a process to occur, as we have already discussed this. There does not exist some directional law which would tell us whether a particular process occurs or not. This answer is provided by, so this directional direction in which the process takes place and all, this directional law would tell about the second law of thermodynamics. That means in second law of thermodynamics, we will study about the direction, but whereas in first law of thermodynamics, we will study only up to the rate of transfer, that is amount of transfer of work and heat between the system and surroundings. Up to that only we will study in first law of thermodynamics. So this is the basic experiment for first law of thermodynamics. So this experiment has different names. First one name is, it is also called as first law for a closed system undergoing a cycle. That means closed system is a system in which there is only mass transfer, there is no mass transfer, there is only energy transfer. That means work and heat can interact, but there is no mass flow of water into the system or out of the system. Okay, so first law for a closed system undergoing a cycle. So cycle should be completed for a closed system, and if we apply this first law for this closed system undergoing a cycle, so this is the experiment. So this experiment is also called as Joules experiment, and it is also named as verification of first law of thermodynamics. So, and it is also called as experiment to determine the Joules experiment, Joules equivalent or mechanical equivalent of it. So these are all the names that we have for calling this experiment. So what is this experiment is? So in this experiment, we will take one vessel here. So this is the vessel which is a closed system. So we will consider this closed vessel as one system. System means there is no mass transfer. Closed system means there is no mass transfer and there is only energy transfer. That means only work and heat can interact with the system and surroundings. So this vessel is taken as a closed system. So if it contains mass of water here, okay, And for example, at the starting point, we will insulate this one. Insulate this one means there is no heat transfer between the vessel and the closed system and the surroundings. So if you insulate this one, there will be no heat transfer. So at this condition, what we will do is we will take one stirrer here, and this yellow color region is a stirrer. So if you stir this one, what happens is the water inside this vessel will get slightly. So if we take initially this water is at a temperature T1. So if we go on stirring this water, the temperature will increase to temperature T2. Okay. So after reaching the temperature T2, so the pressure is maintained constant. So if now at this position, that means when the temperature increases from T1 to T2, so if the insulation is removed, so what happens if the insulation is removed? So there is an interaction between system and surroundings. That means the heat is transferred from water to surroundings. Okay. So in order to maintain the equilibrium condition of the temperature or thermal equilibrium with the atmosphere. అంటే మనం ఒక క్లోజ్డ్ వెసల్ తీసుకొని, సో ఇఫ్ యూ టేక్ ఎనీ వాటర్ ఇన్సైడ్ ద క్లోజ్డ్ వెసల్ తీసుకున్న తర్వాత ఏం చేస్తామంటే ఇది క్లోజ్డ్ సిస్టమ్ అంటాము. క్లోజ్డ్ సిస్టమ్ అంటే ఎప్పుడు అంటే దీంట్లోంచి వాటర్ అనేది బయటికి వెళ్ళదు, అంటే మాస్ ట్రాన్స్ఫర్ అనేది ఉండదు, ఓన్లీ ఎనర్జీ ట్రాన్స్ఫర్ మాత్రమే ఉంటుంది. ఎనర్జీ ట్రాన్స్ఫర్ అంటే వర్క్ హీట్ ఇంటరాక్ట్ అవ్వచ్చు అనమాట. సో అలా ఉంటే మనం దాన్ని క్లోజ్డ్ సిస్టమ్ అంటాము. సో ఆ క్లోజ్డ్ సిస్టమ్ లో ఇఫ్ యూ టేక్ ఎనీ స్టిర్రర్, సో స్టిర్రర్ యూస్ చేసి స్టిర్ చేసేటప్పుడు ఇనిషియల్ గా దీని టెంపరేచర్ వాటర్ టెంపరేచర్ T1 ఉంటే, సో నేను ఇన్సులేట్ చేశాను. ఇన్సులేట్ చేస్తే ఏమవుతుందంటే లోపల ఉన్న హీట్ బయటికి వెళ్ళదు. సో అలాంటి పొజిషన్ లో ఇఫ్ యూ గో ఆన్ స్టిర్రింగ్ దిస్, ఏమవుతుంది లోపల ఉన్న వాటర్ టెంపరేచర్ అనేది ఇంక్రీజ్ అవుతుంది. సో ఇంక్రీజ్ అయినప్పుడు దీని ఫైనల్ టెంపరేచర్ T2కి వచ్చింది. సో ఇప్పుడు నేను ఇన్సులేషన్ రిమూవ్ చేశాను అనుకోండి, ఏమవుతుందమ్మా హీట్ ట్రాన్స్ఫర్ అనేది జరిగి ఈ అట్మాస్ఫియర్ టెంపరేచర్ T1 దగ్గర ఉంది అండ్ వాటర్ టెంపరేచర్ T2 దగ్గర ఉంది. సో హైయెస్ట్ టెంపరేచర్ కంటే ఎక్స్చేంజ్ ఆఫ్ హీట్ జరుగుతుంది. ఓకేనా? అంటే in order to attain the thermal equilibrium means maintaining the same temperature with the atmosphere. So ala insulation remove cheyadam valla, so the heat is trying to exchange between the system and surroundings. So now, so if you take this graph, so pressure, volume, or if you take any two temperature, entropy, or pressure and volume as x-axis and y-axis, so 1 to 2 is one process. 1 to 2 work transfer jarugutundi. Stirrer chesina process amma 1 to 2 idi. W1 to 2 is the work done by the stirrer. So 2 state ki vachindi ante temperature 2 state ki vachin tarvata next time avutundi manam insulation remove chesin tarvata heat transfer jarugutundi. Heat transfer jarigi malli original state ki vache varaku heat transfer jarugutundi. So completing a cycle. So in the first stage the work is transferred by the stirrer to the water, and in the second state heat is transferred from the system to the surroundings. Okay, so this is the second process in which heat is transferred, and this is the first process in which work is transferred. Okay, so la jariginappudu em avutundante it has been found out that work done is proportional to heat transfer. Ante enta amount of work ichamo ante heat transfer jarugutundi. So that means if we take the work transfer which is equal to heat transfer, that means work is proportional to Q. Proportionality constant ante em chestamu, we will in order to remove the proportionality constant we will add one constant. Okay, so that constant we will call it as Joules equivalent J. So W is equal to Q for a cycle. Here we have taken only one work transfer jarigindi anukunnala, number of stirrers place chesam anukondi. So if you go on increasing the number of stirrers, so more number of work done will be there. W1, W2, W3 ఇంకో స్టిర్రర్ పెట్టాం అనుకోండమ్మా, ఇది W1 వర్క్ చేస్తే ఇది ఇంకోటి W2 వర్క్ చేస్తుంది. That means a summation of W indicates all the amount of work, all the work transfers if added together gives the summation of work transfer for the cycle is equal to alane heat transfer కూడా. Okay na? So that means W1 plus W2 number of work transfer summation is equal to summation of heat transfers. So these two are proportional, work transfer and heat transfer. So as we go on increasing the work transfer, the heat transfer will increase. Okay, so in order to remove the proportionality constant, we will introduce a constant called as Joules equivalent, which is also called as mechanical equivalent of heat. Okay, so this is the first law of thermodynamics for a cycle. Ikkada cycle complete avutundi kada. So since it is done for a cycle, so this is the first law of thermodynamics for a cycle. Okay, summation of W is for a cycle is equal to summation. Summation means that is integration. Okay, summation means in integration only we will add all the components, whereas in differentiation we will differentiate all the components. So integrals, cyclic integral of W is equal to cyclic integral of Q. So J is the proportionality constant, which we will call it as Joules equivalent or mechanical equivalent of heat. Okay. So here the headings are first law for a closed system undergoing a cycle. For a cycle only we will take this formula. And it is also called as Joules experiment. So we will verify the verification of first law of thermodynamics is what is first law of thermodynamics? The conversion of heat energy to work energy or work energy to heat energy. That means principle of conservation of energy. So principle of conservation of energy means only depends on energy transfer. So we have verified this first law of thermodynamics by using this experiment. So it is also an experiment used to determine the Joules equivalent. So this is called as the Joules experiment. So this experiment is done to determine the Joules equivalent, which is also called as mechanical equivalent of heat. So these are all the names for this experiment. Okay. So this summation can also be expressed in terms of integral, as since it is done for a cycle. So we have to represent with cyclic integral here. So cyclic integral of dw is equal to j into cyclic integral of dq. So here this symbol cyclic integral denotes a for a closed path, since it is a closed path here. So 1 to 2 and 2 to 1 is a closed path. This cyclic integral, in terms of cyclic integral, we will represent that cycle. So this is the first law of thermodynamics for a cyclic process. Okay, cycle. So the units of J is Newton meter per joules. So the units of joule per joule, or we can take. So the units of work, joule can be written as joule equivalent can be written as cyclic integral of dW divided by cyclic integral of heat. The units of cyclic integral of dW is Newton meter, and the unit of heat transfer is joule. So the unit of J is found to be unity. That means it will have no units, because both are energy transfers. It will have no units. So coming to the definition of calorific theory of heat. So what do you mean by calorific theory of heat? Means heat will always flow from a higher temperature body to a lower temperature body. Okay. So and that heat that is transferred from higher temperature, we can call it as higher calorie also. That means higher energy body to a lower energy body. The heat which is transferring between those two bodies cannot be a visible fluid. That means we cannot see that heat. That means it is an invisible fluid. So heat is an invisible fluid which we cannot see, will flow from a higher calorie body to a lower calorie body. So this statement is known as calorific theory of heat. Calorific means it is a measurement of heat. Okay. So that measurement of heat means heat will always flow from higher energy body to lower energy body. So this is the definition for calorific theory of heat. And next, coming to corollaries of first law of thermodynamics. Basically, there are three corollaries of first law of thermodynamics. The first law of thermodynamics, first corollary is first law that is applied to a process. Okay. So until now, we have discussed only the first law that is applied to a cycle. Okay, what happens if a first law is applied to a process is, so for example, if you take any process, so if you take 1 to 2 process only, so in this direction or any work direction, so at state 1, there is a lot of work transfer here. When it comes to state 1 to state 2, okay, the energy is converted into work here. So if we give an work energy, all the work energy that is converted, it is given as input here, cannot be reached by state 2. So for example, if to explain clearly, if you take any body, so if you take here any body here, any system, if you push the system here, for example, if you apply some force or if you give some work here into the system as for example 10 kilojoules something, so by applying this 10 kilojoules of work to the system, so the system will not take all the 10 kilojoules. Okay, so it may be converted into heat. Let us say it is converted, only 9 kilojoules of work is converted into heat. That means if 10 kilojoules of work, మీరు 10 kilojoules of work ఇచ్చి ఆ సిస్టమ్ ని మూవ్ చేయడానికి ట్రై చేస్తే, ఆ సిస్టమ్ ఆ వర్క్ తీసుకొని హీట్ గా కన్వర్ట్ చేసింది అనుకుందాం. దట్ మీన్స్ ఇట్ విల్ గివ్స్ ఓన్లీ 9 kilojoules of heat. So what about the remaining 1 kilojoule is the system will store in itself. ఓకేనా, ఆ సిస్టమ్ లోనే ఉంచుకుంటుంది. ఆ సిస్టమ్ లో ఎంతైతే స్టోర్ చేసుకుంటుందో అది ఎక్కడి నుంచి వస్తుందమ్మా, విచ్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ W and Q. ఓకే, సో దట్ ఎనర్జీ వి విల్ కాల్ ఇట్ యాజ్ ఇంటర్నల్ ఎనర్జీ. ఏదైతే మనకి స్టోర్ చేసుకొని ఉంటుందో సిస్టమ్, తనలో దాన్ని ఇంటర్నల్ ఎనర్జీగా తీసుకుంటాం. దట్ మీన్స్ ద ఎనర్జీ స్టోర్డ్ ఇన్సైడ్ ద సిస్టమ్ ఇట్ సెల్ఫ్ ఈస్ కాల్డ్ యాజ్ ఇంటర్నల్ ఎనర్జీ. దట్ ఈస్ గివెన్ బై ద డిఫరెన్స్ బిట్వీన్, అంటే వర్క్ కి హీట్ కి మధ్య ఉన్న డిఫరెన్సే ఆ స్టోర్ చేసుకున్నది అవుతుంది అనమాట. ఓకే, సో దిస్ ఈస్ ద ఫస్ట్ లా for a process. Okay, so where E here is called as a property of the system, which we will call as a total energy that is stored inside the system. So ఈ total energy అనేది internal energy form లో ఉండొచ్చు, kinetic energy లాగా స్టోర్ చేసుకోవచ్చు, potential energy, electrical energy, ఎనీ ఫామ్ లో, ఏ ఫామ్ లో అయినా సరే ఆ సిస్టమ్ లో స్టోర్ చేసుకోవచ్చు అనమాట దట్ టోటల్ ఎనర్జీని. సో దిస్ ఈస్ ద ఫస్ట్ corollary of first law of thermodynamics. And coming to second one, for an isolated system. Isolated system అంటే ఏంటి? There will be no mass transfer and there will be no energy transfer. Both the Q and W becomes zero for an isolated system. So if in this equation, if both Q and W are zeros, what happens to E? E will also be zero. Okay, that means E అనేది కాన్స్టెంట్ గా ఉంటుంది, అంటే DE అనేది జీరో అవుతుంది. DE జీరో అంటే దాని మీనింగ్ ఏంటి? డిఫరెన్షియేషన్ ఆఫ్ ఎనర్జీ ఈజ్ జీరో. దట్ మీన్స్ దెర్ ఈస్ నో చేంజ్ ఇన్ ఎనర్జీ. సిస్టమ్ కి ఇనిషియల్ గా ఎంత ఉందో ఫైనల్ గా కూడా అంతే ఉంది, ఇంకేది యాడ్ చేయలేదు, రిమూవ్ చేయలేదు కాబట్టి. ఓకే, సో దట్ మీన్స్ చేంజ్ ఇన్ ఎనర్జీ ఈజ్ జీరో. దట్ మీన్స్ ఎనర్జీ రిమైన్స్ కాన్స్టెంట్. ఓకే, so energy can neither be created nor be destroyed. However, it can be converted from one form to another form. That's why we are taking this energy as constant. Okay, coming to third corollary, it is a PMM1. PMM1 means it is defined as perpetual motion machine of third kind. So this third kind, this is the perpetual motion machine of third kind. So in first law, we have stated that first law of thermodynamics is a principle of conservation of energy. That means energy can neither be created nor be destroyed. That means it should be converted from one form to another form. Okay, or it can be converted from one form to another form. So this is violated. The violation of this statement is the perpetual motion machine of first kind. Okay, violation means here if you take this PMM1, it is if we treat this as a machine, so this machine can supply work here. That means this machine can give us work without taking any heat. So it is impossible. But that means any machine cannot give any work as output without taking some input energy. For example, if you take air compressor or anything, so that air compressor will not give any work as output without taking electrical energy. Okay, so that means it has to take some amount of energy in the form of electricity or anything in order to give work as output. Okay, so there will not be any machine which will give continuously work without consuming heat. So the reverse of this statement is, so if you give any work to any system, so this work completely cannot be stored by the system itself. It should be dissipated in the form of heat. Okay, so మీరు కంటిన్యూస్ గా వర్క్ ఏదైనా ఒక సిస్టమ్ కి ఇచ్చినప్పుడు ఏమవుతుంది అంటే అది ఏదో ఒక విధంగా సిస్టమ్ నుంచి వర్క్ మనం తీసుకోవాలి, అంటే హీట్ అలాగే డిసిపేట్ అవ్వాలి, ఇంకో ఫామ్ లాగా డిసిపేట్ అవ్వాలి, అంతేగాని సిస్టమ్ మొత్తం కూడా వర్క్ తీసుకొని ఉండలేదు. ఓకే, దీనికి రివర్స్ ఇదమ్మా, అంటే ఒక సిస్టమ్ వర్క్ ఇస్తుంది అంటే మనకు ఒక మెషిన్ అది ఎలక్ట్రిసిటీ కానీ ఏదో ఒక ఎనర్జీ కానీ తీసుకొని ఉండాలి, కానీ తీసుకోకుండా ఎనర్జీ ఇస్తుంది అనేది ఇంపాసిబుల్. సో దిస్ ఈస్ అన్ ఇంపాసిబుల్ టాస్క్. డాటెడ్ లైన్ ఇండికేట్స్ హియర్ ఇట్ ఈస్ నాట్ టేకింగ్ అని. ఓకేనా, అంటే వర్క్ ఇస్తుంది కానీ హీట్ తీసుకోవట్లేదు అని అంటే ఇది ఇంపాసిబుల్. అలానే వర్క్ ఇస్తున్నాము కానీ మనకు హీట్ ఇవ్వట్లేదు అని అంటే ఇట్ ఈస్ ఆల్సో అన్ ఇంపాసిబుల్. సో బోత్ ది లాస్ ఆర్ వయోలేటింగ్ ద ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్. దట్ మీన్స్ వర్క్ అండ్ హీట్ ఆర్ ఫార్మ్స్ ఆఫ్ ఎనర్జీస్. ఓకే, సో వర్క్ అనేది ఎనర్జీ ట్రాన్స్ఫర్ జరుగుతుంది కానీ హీట్ అనేది తీసుకోవట్లేదు అని అంటే వయోలేషన్ ఆఫ్ ఫస్ట్ లా. సో దిస్ ఈస్ ఆల్సో ఓకే. సో these two types of machines which is impossible tasks are called as perpetual motion machine of first kind. Okay. In today's class we have studied about first law of thermodynamics and what is Joules experiment, and also what is the statement of first law of thermodynamics for a cyclic process, definition of calorific theory of heat, and the corollaries of first law of thermodynamics with perpetual motion machine of first kind. Okay.